Hello, everybody. My name is Roman Rodriguez, and we are doing physics. We are on chapter 7, circular motion and gravitation. This is the first lesson of this time. So, here we will be discussing about uniform circular motion. We'll also be studying about the Newton's law of gravitation and how do we calculate the mass of the Earth. So, we'll be covering all these topics in this lesson. So first, to understand what is uniform motion, the movement of a body following a circular path is called circular motion, and the motion of a body moving with constant speed along a circular path is called a uniform circular motion. Now here remember that the speed is constant but the velocity changes. Why? Because when a body is moving in a circle, it changes its direction at every instant. So if a particle is moving in a circle, it must have some acceleration and which is acting towards the center, which is making it move around the center. Since the acceleration is perpendicular to the velocity of the particle at every instant, it is only changing the direction of the velocity and not the magnitude. And that's why the motion is called uniform circular motion. And we call this acceleration centripetal acceleration. Example of uniform circular motion is that of a motion of a satellite around the Earth. In any example, you can see that the gravitational force from the Earth makes the satellite stay in a circular orbit. And the motion of electron around its nucleus, the motion of blades of the windmill, the tip of second hands of a watch, which has a circular dial. It all these motions they move with a constant speed, and we call it a uniform circular motion. Now, remember, I did mention about acceleration and centripetal acceleration. So just remember that if a particle is moving in a circle, it must have some acceleration acting towards the center. Since this acceleration is perpendicular to the velocity of the particle at every instant, it is only changing the direction of the velocity and not the magnitude, as I discussed earlier. So we call this acceleration centripetal acceleration, and the force acting towards the center is called the centripetal force, right? So centripetal acceleration mathematically can be calculated as AC is equals to V squared upon R, and the centripetal force, according to Newton's second law, F is equals to ma. If we replace A with centripetal acceleration, then the centripetal force will be mass times velocity squared upon R. Right, centripetal force and centrifugal force. Now, what is the difference between the two? Centrifugal petal force is the force that is necessary to keep the object moving in a curved path and directed inward, whereas centrifugal force is defined as the apparent force that is felt by an object moving in a curved path that acts outward, so from the center of rotation. So this is the difference between centripetal and centrifugal force. Force acting inward is centripetal, and the force that is directing outward is called centrifugal. Now, centripetal force and centrifugal force are really the exact same force, just in opposite direction, because they experience from different frames of reference. So if you're observing a rotating system from the outside, you see an inward centripetal force acting to constrain the rotating body to a circular path. So just remember this. And how, if you are part of a rotating system, you experience an apparent centrifugal force pushing you away from the center of the circle, even though what you are actually feeling is the inward centripetal force that is keeping you from literally going off on a tangent. Now, let's move on to Newton's law of gravitation. Newton's law of gravitation was first put forward by Sir Isaac Newton in 1687, and according to him, the force of attraction between two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So here, if you notice that we have a formula for this, that is F is equals to G m1 m2 upon r squared. Now G is the constant of proportionality called gravitational constant, and you can see over here a century later, after Newton, Henry Cavendish determined the proportionality constant G by performing a painstaking experiment, and he constructed a device similar to that which is shown over here in the figure. Once when it is in equilibrium, two fixed large masses are placed symmetrically near the smaller ones, and the gravitational attraction creates a torsion, a twisting in the supporting wire that can be measured. Okay, just remember the gravitational constant has a fixed value which is 6.67 times 10 to the power of minus 11 Newton meter squared per kilogram squared. In future, I'll be discussing and deriving this equation also. Uh, in my future lesson, so let's move ahead. Now we need to know how mass of the Earth is calculated. Now, mass of the Earth may be determined by using Newton's law of gravitation. That is, force is equals to G m1 m2 upon r squared. M1 m2 are the two masses, and r is the distance between the centers. So uh, we know that acceleration due to gravity has a fixed value 9.8 meter per second squared, and gravitational constant, which is capital G, has 6.67 times 10 raised to the power minus 11 Newton meter squared per kilogram squared. If the radius of the Earth is known to us, 6.38 into 10 to the power 6 meter, mass can be calculated. As you can see over here, that when you are taking two bodies, m1, m2, according to Newton's gravitational law. So let's suppose one of the two masses um, is the mass of the Earth, and the other is a mass which is at a distance. So what do we get? We get g m1 m2 upon r squared, and we know according to Newton's law, second law of motion, F is equals to ma. So when I compare the two, I'll get the mass and mass will cancel out one, and then you're left with g m upon r squared is equals to g, and g is your acceleration due to gravity, which is 9.8 meter per second square. R is the radius of the Earth, which is 6.37 into 10 to the power of 6, and the gravitational constant is 6.67 times 10 to the power minus 11. So when you substitute all these values, you will get mass of the Earth, which is approximately 6 times 10 to the power of 24 kilogram. So here we discussed motion moving in a circle. We discussed about centripetal acceleration, of course, centripetal force and centrifugal force, and we also uh, discussed the Newton's law of gravitation. And with the help of this Newton's law of gravitation, we calculated the mass of the Earth. Hope you all in the next lesson. Till then, take care.